The final way to find a limit is either analytically or it's also known as algebraically. This is probably the most commonly used method and the method that teachers and the AP test will expect you to know how to do in order to find a limit. So there's actually subcategories for finding a limit algebraically. The first one is direct substitution. Direct substitution is when you're given a function that you have to find the limit of, and you're able to just plug in the value that you're plug in the x value that you want to find the limit for, and you don't have to worry about getting a 0 in the denominator. So an example is find the limit as x approaches 1 of x squared plus x plus 2 all divided by x plus 1. So first thing you do is you want to check to see if your denominator is going to equal 0 if you plug in whatever x value you're trying to find the limit of. And so if you take 1 and plug it into the denominator, you get 1 plus 1, and that does not equal 0. So this example can be used for direct substitution. So that means that you would just plug in 1 wherever there's an x. So 1 squared plus 1 plus 2 all divided by 1 plus 1. That's going to equal 1 plus 1 plus 2, which is 4, divided by 2, and 4 divided by 2 is going to equal 2. So that's going to be your limit. The second subcategory is through factoring. Sorry. And factoring is when you will have a 0 in the denominator, and so in order to try and fix that, you're going to try to factor your numerator so that you can cancel something from your denominator. So here's the example for that one. Find the limit as x approaches 1 of x to the third minus 1 all over x minus 1. Well, x to the third, and just a side note, whenever you're factoring, always bring down your limit as x approaches 1 until you actually plug in your x value into your function. So as long as there's x's in your function, then bring down the limit. So then x to the third minus 1 actually factors to x minus 1 times the quantity x squared plus x plus 1. And that's divided by x minus 1. And I'm just going to put this in parentheses so that it's easier to see. From here, you can see that the x minus 1s can cancel out of the numerator and the denominator, which leaves you with the limit as x approaches 1 of x squared plus x plus 1. From here you can do direct substitution, which means that you can drop your limit, your little limit annotation, 1 squared plus 1 plus 1, and that's going to equal 3. The third method is rationalization, and you're likely going to do this when you have to find the limit of a function where there's a square root involved, or some sort of root. And what you're going to be looking for is to multiply by the conjugate. So just a quick reminder on what the conjugate is. If you have the square root of x minus 1, then the conjugate is going to be the square root of x plus 1. You're just going to flip the sign that's inside the, that's within the binomial. So for this problem, find the limit, limit as x approaches 0 of this function. So first thing you want to check for is direct substitution. If you were to substitute 0 right into the problem, you'd get 0 on your denominator, which means that direct substitution does not work in this case. So next thing you would look for is, since there's a square root involved, you can you want to look to multiply by the conjugate. In this case, that conjugate is going to be of the numerator, so you're going to multiply by square root of x plus 1, change the sign, so that's going to be plus 1, and all over, because essentially you're just multiplying by 1. I mean, the square root of x plus 1 divided by the square root of x plus 1 is just 1. So after doing some foiling, you get the limit as x approaches 0 of x plus 1 minus 1 all over x times the square root of x plus 1 plus 1. I would suggest whenever you're multiplying it out, whichever, whether it be the numerator or the denominator, whichever one you're not rationalizing, leave it in leave it as a product. Don't FOIL it out, because usually the case is that something's going to be able to cancel out so that you can use direct substitution. So when you simplify this down, you get the limit as x approaches 0 of 1 minus 1 is 0, so just x over x times the square root of x plus 1 plus 1. And here you can see your x's cancel out, and so that leaves you with, bring it up here, the limit as x approaches 0 of 1 all over square root of x plus 1 plus 1. Now you can substitute in your 0, so that gives you 1 over square root of 1 plus 1, which just equals 1/2. And there's your limit. Now, there are special trig functions that you need to be aware of. I would suggest just memorizing them unless you want to look for the proof on them. But the limit as x approaches 0 of sine of x over x equals 1. And what this means is that so long as the angle equals the denominator, then it's going to equal 1. This also can be flipped. Because 1 is just 1 over 1, the reciprocal will not matter. However, with cosine, it's the limit as x approaches 0 of 1 minus cosine x over x is going to equal 0 as well. So find the limit as x approaches 0 of x over sine of 3x. First thing you're going to want to do is determine that you're going to be looking for something of this sort. So in this case, it's likely going to be this one since the sine of x is on the bottom. And what you want to do is get this angle to equal your numerator. In order to do that, because of the scalar multiple rule, you can multiply this function with 3 over 3. That gives you the limit as x approaches 0 of 3x all over 3 sine of 3x, because this doesn't multiply with the angle. This comes out in front of the sine. Once you do that, you can see that you have this limit of 3x over sine of 3x. The angle and the numerator agree, which means that because of the scalar multiple rule, you can pull out this 3 in the denominator and make it a 1/3 times the limit as x approaches 0 of 3x all over sine of 3x. This all just equals 1, so your limit is 1/3. And finding the limit as x approaches 0 of 1 minus cosine squared x, first thing you're going to want to do is just, since you can't do direct substitution right there or anything, you're going to look to use this rule so you can actually factor out your numerator as a difference of two squares. All over x. Because of the scalar multiple rule, you can pull out this section right here to the front so that you get 1 plus cosine x times the limit as x approaches 0 of 1 minus cosine x over x. According to your rule, this right here is going to equal 0, so that's going to be 1 plus cosine x times 0, which equals 0.